Hello, everyone. It's a great pleasure to be here today, joining you remotely to share our contribution and the new feature to open source community Trino. Especially, we will be discussing our work on the Snowflake connector for the Trino project. I'm Teng Yu, representing ForePaaS, and with me is Eric Anderson from Bloomberg. Together, despite the physical distance, we have collaborated to make a significant impact in Trino ecosystem through our work on the Snowflake connector. Over the next 30 minutes, we will take you on a journey to explore the background, motivation, and the exciting new features we have introduced with the Snowflake connector. Acting as a bridge between Trino and Snowflake, the Snowflake connector aims to facilitate efficient and reliable data interactions. Its development addresses the challenge encountered during the integration of Trino and Snowflake, providing users with enhanced experience and expanded application scenario. From now on, you can track the progress of the final pull request by this link. I'm sure it will be available to you soon. We would like to express our sincere gratitude to Trino organization for giving us this opportunity to share our work with all of you. We firmly believe that the Snowflake connector brings added value not only to Trino and Snowflake users, but also contributes positively to the development of the open source community as a whole. So without further delay, let's embark on this journey together as we explore the world of its Snowflake connector. Thank you. In my part, I will be covering 4 aspects. Firstly, I will introduce myself and provide an overview of ForePaaS, the company I represent. Next, I will introduce Snowflake and why ForePaaS needed. Then, I will highlight the key features of the connector that have made it an essential component of our data integration strategy. My name is Teng Yu, and I'm a full-stack developer at ForePaaS, an OVH cloud company. ForePaaS is a modern data platform for creating, deploying, and scaling AI projects easily on the cloud. Based in Paris, ForePaaS was founded in 2018. In 2014. In 2018, ForePaaS expanded in the United States by opening its first office in San Francisco, and was acquired in 2022 by OVH Cloud, the European leader in cloud computing, to drive its big data and analytics software initiative worldwide. As you can see, overall, this is what ForePaaS looks like. This covers all our different products and services, especially some services like data manager and analytics manager will be important. Data manager uses Snowflake and analytics manager uses Trino. Let's talk about Snowflake. Snowflake is a cloud-based data warehousing and analytics platform designed for the modern era of data-driven decision-making. It offers an unparalleled combination of scalability, flexibility, and performance, enabling business to unlock the full potential of their data. Snowflake's unique architecture separates compute and storage, allowing organizations to scale their computing resources independently based on their specific needs. The elastic eliminates the need for upfront hardware investments and provides the agility to adapt evolving data workloads. In a word, Snowflake has emerged as a leading data platform, empowering organizations to efficiently store, process, and analyze massive amounts of data in cloud-native environment. Its native feature and scalability make it natural for organizations like ours, where data integration and analytics play a crucial role in driving insight and decision making. Why ForePaaS needed the Snowflake connector? At ForePaaS, we support Snowflake as one of our major storage engines for our data warehousing service, aka ForePaaS Data Manager. Since Trino powers our query and data-wise service, aka ForePaaS Analytics Manager, which allows users to fire SQL queries on both their registered data sources and their data warehouse. We rely on underlying Trino connectors for this interoperability. Is crucial for us to have a Snowflake connector to ensure the compatibility of Analytics Manager service with the users who wanted to use Snowflake as their storage technology. Now let's talk about the connector features. In fact, it is a full-feature connector. It serves as a robust bridge between Trino and Snowflake, enabling users to harness the full potential of both platforms. This connector embodies the vision of Trino full-feature connector, offering a wide range of capabilities to enhance data exploration, analysis, and processing. With the Snowflake connector, users can seamlessly access the query data stored in Snowflake directly from Trino, eliminating the need for complex data transfers and duplication. This integration empowers the organization to leverage the power of Trino distributed query engine while harnessing the scalability, flexibility, and security feature of Snowflake. Moreover, the connector leverage Snowflake's optimized architecture and distributed computing capabilities, ensuring high performance and scalability for processing large data size. It seamlessly adapts to change workload and harness the power of Snowflake elasticity to deliver optimal query execution. Our collaboration with the Trino community and our commitment to open source values have driven us to contribute to this powerful Snowflake connector. We extend our gratitude to the Trino community for their support and collaboration throughout the development process. Now let's shift our focus to the next part. It's my pleasure to introduce Eric, who will share insights about himself and his affiliation with Bloomberg. But that's not all. We have an exciting demo show lined up for you as well. Please give a warm welcome to Eric.
Thanks, Dane. It's a great working with you on this connector. It was a collaboration between the two companies and us two individuals to make it work. All right. Okay, I'm Eric Anderson. Here's my LinkedIn if you want it. Please mention this Trino Fest talk in your LinkedIn request. Or I've been a software engineer for over 30 years, aka a lot of people call it senile engineer, not senior engineer. I've been working in the open source for at least 20 years and about 3 some years just in Trino alone. And I need to give the financial services standard disclaimer. My many opinions are my own. Okay. I'd like to share one small thing about Bloomberg. Bloomberg is a very large company. It'd be kind of hard for me to go into depth of everything that we do. But in the last 2 decades, Bloomberg has culturally shifted from a private closed source company to an open source first company. So we have many hundreds of individuals across the company that are involved in open source from all over the world. And of course, one of those is Trino itself. Next slide. Okay, Bloomberg's need for Snowflake. Well, one, it's open source. We love open source. And 2, I don't really discuss Bloomberg use cases. I'm sorry. We don't really discuss how we use the technologies and what problems we use to solve. But instead, I would like to give an interactive demo, a live demo of how you can use Snowflake to solve some very interesting business challenges. And then I will use that same technology to be able to take a brand new derived data set that I live created on the fly, and we'll publish it directly to Snowflake. Why? Snowflake has a very nice Snowflake data marketplace where you can take your data and you can turn around and sell it. So, which is what I would call a standard workflow that many of the industry will want. Okay, then can you go to the next slide? Okay, this is demo time. Okay, first is the link to the actual code being used. Okay, all the SQL that I'm going to use in this demo is in that link right there. So you're more than welcome to open it yourself and take a look at the SQL being used. You may be able to search for it too. I think these links will be available later on. Okay. Before I do the demo, I'd like to explain what we're doing. Can you go to the next slide? Okay. In this demo, I'm going to have a local version of Trino running on my PC. I'm going to have a local version of Apache Superset running on my PC. I'm going to have a Apache Hive Metastore running on my PC, and I have a MinIO. So everything is going to be local on my PC. I'm going to create a brand new data set on the fly, and I'm going to use this technology to be able to transfer this data directly to Snowflake. There will not be a single ETL pipeline built. It'll be purely SQL-based workflows, start to finish. There will be no data engineering involved, and you're going to be able to move at the speed of business insights, and not just long meetings. And to give you an idea that I did this kind of work 15 years ago, and I would call it in C and C++. So I'm going to try and reproduce the many months of work in about 10 minutes. Can you go to the next slide? Okay, well, go back. Let me do the demo. Can I take over the share?
Yes, of course.
Okay. Screen. Okay, let me move this out of the way. Okay, first let me explain what you're seeing here. On the left-hand side, you'll see the Snowflake console. So we'll see I have no data currently in the Snowflake console. What I'm going to do is I'm going to take this particular data set. It's an Uber data set. It's a public data set. I'm going to have it downloaded, which I have locally. Okay. I don't need this anymore. On the right-hand side, I have a tool called Apache Superset. I'm going to build the entire data set in Superset. I have MinIO running. MinIO is it's an S3 compatible system, very similar to what Amazon S3 is. And then, of course, I have my running Trino cluster. Okay. So the first thing we need to do is we need to get data. I've already downloaded the Kaggle data set, and it's an Uber. So the first thing, let me create a brand new Uber subpath, and let me upload the data set. So what the data set is, it's just an Uber CSV file, right? Publicly downloaded, upload. Now it's sit there and stored. We go back to Superset. I'd like to go to an SQL lab, but I think what you'll find is the first thing in Superset, which is brand new, I just launched it. You have to add a data set or a database.
I think we
add the database. Pick Trino. I go to the link. Advanced SQL Lab. I'm going to expose all the data in SQL Lab. Boom. Allow DDL multi-schema and allow it to be explored. Connect. You have to wait while you'll see my little window over here. While Trino goes through and does a bunch of loading, and in the other window you'll see all the Hive Metastores and Superset running. Now it's loaded. Move it back. Let's go to the actual SQL tab. Okay, in this tab, let me expand it, make it a little bit easier for everybody to see. Zoom in a little. These are all the SQL commands I'm going to use to create the data set on the fly. First, let's verify that we're really connected to Trino. I do a show catalogs, and you'll see that I have the Apache Hive I mentioned. I have the Snowflake, so this is a remote Snowflake. I'm connecting the cloud and the system. Let me please create the schema in Snowflake. So I run the schema in Snowflake. I run that schema and create in Hive. Now just To double check, let's make sure that the schema showed up in Snowflake. Oh, sorry, that was show schemas. Yeah, create it. And create the second one. Now let's refresh.
Maybe even look at the
Oh,
maybe I'll just.
that's because I
I'll definitely try to get rid of one of them. I think so that we have to.
didn't quite get the clicks working.
Yeah, that would be fun. It's based on one. It's just like okay, I'm still in compliance with the other one, so I'm just gonna
Allow MDDO.
increasing the memory.
Finish. That basically was superset not letting me do those kind of statements. Go back again to the SQL Lab, SQL Editor. Let's rerun the create schemas, both of them at the same time. Okay, now let's double check that it actually worked in Snowflake. Now we have a new Trino Fest live created in Snowflake. We also have a local one too as well. Okay. Let's go down a little bit more. So the first thing I'm going to do is I'm going to now mount a Trino table on top of that CSV that I loaded further. Okay, run it. Now that's going to basically create a view. Because I had to do varchars because of CSV, right? Everything needs to be interpreted as varchar data. Run it. Okay, yes, it worked. Let's do a select just to make sure I can see the content. I'll do the content. And you'll see that what you're seeing here is just stock data, standard stuff that you would see in Bloomberg, but of course this is a public data set. So you have the date, the open, high, low, close, adjusted, in volumes. Okay. What I need to do now is try and convert that data to the type that I can actually do some analytics on top of. So I'm going to create a view. No data created, of course, it's just a view. Describe the view. Okay. Now I want to actually select the data, make sure it actually works. Okay. So yes, it just pulled it, but you'll see I have some garbage at the top. Because why? I was too lazy. I didn't want to go through and clean the CSV first. I wanted to use SQL to transform that data. So no ETL was required. I will just use SQL. So now I need to remove the headers, otherwise just my math is not going to work. Now, yes, now we have the standard values, the adjusted, and the proper types too as well. Okay. Now, what here is going to create a table if it doesn't exist in Uber. And before I run that, let me jump back out one more time. Let's go to the warehouse. Now you'll see that under the warehouse, I have a Trino Fest, easy, and now there's nothing currently in here at all, right? The data is empty. Let's run this particular command, and what it's going to do is it's going to create a table from the view. And that's actually going to copy that and transform the data into, yes, MinIO. Let's do a refresh. Now you see a brand new Uber table and a bunch of Parquet files. So without doing any work, I just let SQL and Trino do its work. Once again, no data engineering involved. Now I need to do some super fancy calculations, so I kind of mentioned on. What I'll do is I'll do a standard deviation on the previous 10 days. So first a moving average of the data, and then I'm going to do a standard deviation and, you know, basically don't tell anybody. Yes, ChatGPT wrote this particular statement. And as soon as my manager found out that ChatGPT created it, he thought it was not so smart anymore. So first, let's just run it as one giant SQL statement to make sure that it's actually going to work. And then we'll kind of explain what we're seeing. Okay, so on the fly, the two real columns were date and adjusted close. These other three columns are basically, it's a moving average. It's a standard deviation of that moving average on upper envelope and a lower envelope. So these are thin synthetic columns. We basically created those on the fly. Okay, well, so I don't have to go back and ask ChatGPT anymore on how to do that. Let me do this one more time. So I'm going to create a view from this content. I'm going to run it. No data was created, of course. Now let me run a little select. Okay. Now here's the standard deviation. So this is the actual vessel. Let's go back to MinIO one more time and look. It's a view. No new data was created. Nothing. It's just a view. Let's go back to here. So I'm going to create a table if it doesn't exist from the view. I want to run the selection. I'm going to call it envelope data. Okay. Let's jump back to MinIO again. Let's refresh. Envelope data. SQL did the whole transformation. This is once again MinIO running on my local PC. Now let's go ahead and do a select. Make sure it works. Yep. Well, I'm getting the right data. Of course, the standard deviation is 0 for the first week. Okay. Now what I'm going to do is I'm going to take the SQLs above and I'm going to create my envelopes. So this will first do a view to adjust the standard deviation. So it'll take a moving average. It'll take 2 standard deviations above, and it's going to call that the upper envelope and the lower envelope. Let's go ahead and run it. Let's do a select. And now you'll see that we selected from the view. This is the actual content that we want. Now I'm going to take this, I'm going to materialize this content. I'm going to take the view, I'm going to write it straight to the S3, MinIO like we showed before, it's Parquet files. Once again, new row, new data sets. We switch to MinIO and just prove that new data set showed up. Yep, so here's our secret sauce. This secret sauce would be the content that you want to send to Snowflake. That will allow you to then take that unique content that you generated and sell it.
Yeah.
Okay, let me do a select, make sure that we receive the secret sauce. And now let's do a create table. If it doesn't exist, it's called Snowflake. And secret sauce, just to prove one more time, we have no data here at all in Snowflake. Run the selection. And of course, you'll see the window while Trino does its work and copying the data out. So now it says 725 rows. Let's refresh Snowflake. Trino fast. Tables. Secret sauce. Oh my gosh, look. Brand new columns. Data previews. So the content is now in Snowflake. That's pretty cool. But wait, I don't want my demo to stop there. I like to visually take a look at my data and make sure it is exactly what I thought it would be. So let's go ahead and try a little select just to make sure that the data. And you'll see side by side, here's Trino, and on the other window, you'll see the remote data that's currently now housed in Snowflake. Okay. I want to visually represent this content. So what I want to do is I want to go to first data. I'm going to go to data sets. I need to add this data set because otherwise I can't put any charting and graphics on top of it. Select it. Schema, Trino fast, table, my secret sauce. So once again, this table is in Snowflake. Add. Now let's go to charts. Let's create a chart based on this content. I like e-chart types. Time series, because we're building time series content. Drop down, secret sauce, some examples, create new chart. Okay, so this filled this out default for me. Okay, already time columns were filled out and you have a date filter. So let's add some metrics so we can actually look at exactly what we have. Let's do the closed value, just because it's going to help a little bit, and let's do the max.
Yeah,
so the closed value is actually the value that was reported out of the CSV files. Everything else, once again, is synthetic. I'm going to do the standard deviation upper envelope. Oh, wrong one. Once again, upper envelope. Let's aggregate and just the max value just so it'll work. One more time. Simple. Lower envelope. Standard deviation lower. Let's do the max. Save. Now let's try and run the query and see if everything just worked from end to end. It's going to pull the data out of Snowflake and boom. What this is, and to kind of give you an idea of what you're looking at, the middle blue line is the values that came out of the CSV that we downloaded. Okay. The lower is the standard deviation below, and the upper is the standard deviation above. These are what a lot of the folks call trading signals. Pretty much any time that the closed values drop below the standard deviation, something occurred in the market, right? There's something occurred just you should go in and take a look. And as these slopes just scream up, okay, well, if we actually looked at Uber, this is probably some kind of a news announcement or earnings. So we can go back and correlate exactly why particular events caused these spikes. So I would like to go back and just show you in about, 10, 15 minutes, I took a brand new data set using pure SQL end to end. I was able to take the data, I was able to transform it, I was able to, all on the local PC, I was able to put it in a Snowflake, and I was able to put charts and graphs on top of the content sitting in Snowflake. Okay, I'm going to stop sharing.
You can click on top of your, yeah.
There we go. So the amount of work that it took to do that before was months and months and months of engineering. I just reproduced that work in about 10 to 15 minutes. This was something that I had to do in the past in C and C++, and you don't want to know how long it took. And I think I effectively just showed that I was able to do it from start to finish all the way to Snowflake with a target where data would live locally. Yes, because a lot of folks generate their secret sauce, their insights locally, because they're afraid. So I only put the refined content into Snowflake. I'm trying to answer Gerard's example where you would be able to take vendor content, put it in the Trino, and then do your analytics, and then publish some derived content out to Snowflake. All right, that concludes my demo. Anybody have any questions?
That was awesome, Tang and Eric. Thank you so much. For those in the audience, you have no idea how much work this was to get this off the ground. Tang, Eric, and others have been working on this for many, many months. Rebasing, adapting to all the Trinos, changes, fixing tests, making sure it is suitable. And you've been using this in production for quite a while as well. So this is truly amazing. For those of you that want to see the nitty-gritty details, the PR is up in the Trino organization, and we are working very hard towards getting that merged out in one of the next releases. So thank you so much.
Pedro, I was gonna ask that question. I saw it earlier and made a note to bring it back up, but you've asked again. So when is it going to be available? I think I could answer this as well as anyone else could. But Eric or Tang, if you two want to take a crack at it.
Well, Tang and I are tired of supporting this privately. Supporting private connectors is very expensive, very time consuming, very. So by getting this out to the community, not only can everybody else benefit from the work, but it's going to help us too as well.
Yeah, and we're trying to go as quickly as we can. This is a lot of code being merged, and there's still a little bit of work to be done. So I would expect it to be on the scale of likely a month or two. But it could go a little quicker if we kick butt. It could go a little slower if there's some snags. Kind of depends on a few different things. So you'll hear about it when it happens. Keep an eye on the Trino release notes, but I would say right around a month or two is what I would anticipate.
I'm hoping to push it harder than that because it's actually fully rebased. All the tests are passing, and I invite anyone that has the guts to do this to check out the branch, run it as a build, and test it for themselves as well, and let us know if they encounter any issues. But at this stage, it is very, very complete and amazing. I also wanted to point out that this is not just a Snowflake connector that can read data, right? Like this is a full-featured, powerful connector that allows you to write data, create views, all this stuff that Eric showed and more. Very, very nice. Love it.
What is the difference between this one and the Starburst one? Oh, well, okay, I'm decommercializing some Starburst features, I guess is a good way to say. It should be nearly the same, but this is open source. So that means that the community has to support it, right?
It's a completely separate code base, essentially.
It is separate.
What's more, this connector has been tested in our two company production environment for years.
I
think
gave up on
the
the
Scarborough
connector for a while.
Snowflake connector has also been running for a while at a lot of different places. So I would expect them to be pretty similar. It's just this is the open source version, so you couldn't use it for free before, and now it's out there in the wild. So,
and of course,
Well,
this like I also wanted to point out, Eric has been doing an amazing job in this demo, because that's actually like not a common use case of Trino, to have Trino running locally on your workstation, sucking data down and massaging it and putting the data only back up into another system. That's not a common thing, but as you see, that's actually possible, and it's pretty amazing to do that. So thanks for that sort of side hack that was like sort of like a side note of the demo, which is really cool actually.
That was a lot of work to get that thing working appropriately. Oh my God, you wouldn't believe the amount of hiccups and power, laptops turning off, and when Tang and I were trying to demo it, oh boy, it took a lot of work to get that thing nearly flawless.
Well done. Thank you so much again.